Great. So welcome everyone. Thanks for coming out tonight to learn about this new program that we're launching. If you were here for our previous pre-launch webinar a few weeks ago, then it's great to have you back. And if not, then it's nice to have some new folks in the mix as well. My name is Ryan Keith. I'm with Abode Energy Management, and I'm here with my colleague, Mike Simons, who's a technical expert. Also here with Andrea. Would you like to introduce yourself?
Good evening, everyone. I'm Andrea Becerra. I'm the Sustainability Director for the Town of Acton. Very excited to be here. And I'll say a few more words in the next slide or so.
Great. So just a quick roadmap of what we'll be discussing tonight. There's a lot to get through. Mike, could you go to the next slide? I'm stuck on this slide, but that's all right. So we will be talking about the Clean Energy Challenge as an overview. Then we will be talking about the program's objectives and some of the technologies that we're promoting. And at the end, we will open it up to Q&A. And as I mentioned, we will allow everyone to be a part of the panel so that we can see each other and speak together. So if you have a question in the meantime, you can put it through in the Q&A box and we'll do our best to go through those. Some of the more complex questions we'll wait until the end, but we may be able to answer some as we go through. Next slide.
And then the other point about the Zoom, we will open up, everyone will become a panelist at the end so we can all see each other's faces and pretend we're all in the same room together. So Acton has accomplished so much in the last decade when it comes to climate action. We have the greenhouse gas inventory, which was published 2 years ago, or a year ago, conducted 2 years ago, 2019, 2 years ago, by the Green Advisory Board. We have the Climate Emergency Declaration, of course, which called for a better future starting now and was voted for on September 8th. Of last year. We have the Net Zero Ready Fire Station that's going to be open soon, and the Douglas Gates Elementary School, which is also net zero. So a lot of great initiatives that have been already accomplished and ongoing. We have the Climate Action Plan. I'll be posting a link to a workshop that we're hosting, an open house actually, that we're hosting on October 16th. On Saturday, so I'll be putting a little link for you all to register if you're interested in attending. And then there's also Energize Acton, and I failed to include a little graphic of Energize Acton here, but Energize Acton is the initiative that really led to our partnership with Abode. They were pushing for greater action in Acton, and we developed this partnership because of that community-led effort. Energize Acton is an initiative that has a list of actions that residents and homeowners and businesses can take to lower their greenhouse gas emissions and reduce their carbon footprint. One of which is to upgrading to electric heating and cooling systems, which led to our partnership here with Abode. And we'll be promoting the work with Abode on that website. And Deborah is putting a little bit more information. We'll also include a link to the Energize Acton page. Well, thank you, and then I'll pass it on to Abode.
Reading the slides and everyone who's registered week. So if you'd like to reabsorb some, you'll be able.
Andrea, are you having trouble hearing Ryan?
Good.
I am.
Okay. Ryan, it seems like your internet's being a little bit flaky, so I'll just take it from here if that's okay. Okay. Yeah, so we're Abode Energy Management. The main part of our business is we work very heavily in the Mass Save program. We oversee all the home performance contractors on behalf of National Grid. So we're doing a lot of QA quality assurance work. We're making sure that the Mass Save energy audits as well as the weatherization work goes really good. But along the way, we started getting very invested into clean heating and cooling technologies. So that's a big portion of what we're doing right now is we're helping communities such as the city of Cambridge, the town of Acton, and a handful of municipal light plants run their heat pump programs. The goal of our work is really to be working with customers as well, homeowners as well as contractors, because they're the ones who are really always kind of implementing. They're the ones that kind of have the tools in the toolbox to really make this change happen. So we're always trying to be working in a partnership with them. And our goal is really, at the end of the day, is just extremely well-educated homeowners who understand technology and know the right questions to be speaking to contractors about. And just a little bit about me. So my experience with energy efficiency, it's all that I've done in the last 10 years. Along the way, I've run over 1,000 mass save energy audits. I've trained over 100 mass save energy specialists. I'm just really geeky when it comes to this stuff. And just personally, I have a 100-year-old home. We bought it a little over a year ago. In that time, I've gotten it fully weatherized, replaced all the windows with Energy Star rated ones. I now am the proud owner of 6 indoor ductless units, 3 outdoor units. And I have recently put on a solar PV system. I'm just waiting on National Grid to actually install the net meter. So I start actually getting to use those panels. So I'm very plugged into this. I've been through this journey that I think a lot of you want to go on, and I'm happy to be a resource along the way. One thing that I do need to just say is, especially with hearing the initial chat comments, a lot of what I put together today is related with air source heat pumps. We will be talking about ground source heat pumps in a little bit. If you're wondering why there is kind of a disparity as far as why we're talking so much about air source, it's really, I think, related to a few things. One, Massachusetts hasn't done a good job of supporting ground source heat pumps in the past, unlike, say, New York in their NYSERDA program. So our marketplace of contractors is relatively small. So I know that there's always a best practice of like getting 3 quotes. Well, with like getting 3 quotes for geothermal, it's going to be like all of the geothermal installers in the region. So do know that this technology, as far as like if this is the right solution for your home, the projects are going to be coming in a bit more than an air source heat pump program, an air source heat pump project will. But some good news is with the federal tax credit, there's still a 26% federal tax credit, which really does help to bring down the cost of the project, because that tax credit more or less covers the cost of the drilling or the outdoor ground loop. So we will be talking a little bit about it, but I did want to kind of address that at the beginning. If you're kind of like waiting for, like, we will be touching on geothermal, but not nearly at the same level as air source heat pumps. But I'm more than happy to set up another one of these webinars, and we can really dive deep and maybe bring a few ground source heat pump installers on board to further the discussion. So I really wanted to kick off with this because air source heat pumps have been in the news, or at least in my realm, quite a bit recently, because the Boston Globe has recently done a series about where the state is as far as the adoption of this technology. So the big headline was, Massachusetts should be converting 100,000 homes a year to electric heat. The actual number is 461. Well, I'm proud to say that I'm one of I'm one of that 461. The other thing that's interesting about this, and it may be slightly skewed, is a lot more of these systems are being installed, but it may not be covering 100% of the load. So this 461 is just the people who actually took the time to deal with either the DOER or the Mass CEC to take advantage of their rebate program to kind of get credited. So the number is slightly larger than this. But it does talk about a real problem, and this is what the problem is. And it's a really nice article, but I'm just going to highlight some of the zingers. Okay, so this is why there's a problem, and this is what we're going to be talking about today. So I'll read some. Some homeowners said that contractors affiliated with Mass Save dissuaded them from removing their fossil fuel systems and going all electric. Here's another. Mass save rebates, including equipment that is not specifically designed for cold climate heat pumps, i.e. Mass save is incentivizing heat pumps that may have 100% of their capacity at 50 degrees, but only half of their capacity down at 17 degrees, which is really problematic because now you're going to need to be relying on your fossil fuel-based system and not an air source heat pump. Some residents said that they sought to convert their home off fossil fuel. Contractors, including those associated with Mass Save's energy audit program, told them that heat pumps alone could not heat adequately throughout a Massachusetts winter. So I just really wanted to highlight over here that there is a lot of conflicting information on this kind of like highest level of like how energy is working in the home and how the people from kind of like the state with the DPU down to the utilities, down to the energy auditors kind of carrying over this messaging that heat pumps may not work. We're going to be reviewing that later on. And it's also on the contractor levels. They had 5 contractors out, but only one of the 5 was comfortable fully converting them off of fossil fuels. So these are some of the conceptions that are out right now. These are some of the things that the article talked about. So let's talk about how air source heat pumps do work. So how people have been heating their homes forever. So in the last, I guess actually since the beginning of human history, is they've been taking something and setting it on fire and warming themselves or their structure by it. So originally that's wood, it's still used widely, petroleum products, natural gas, propane, those are all some of the products that people have set on fire inside of their homes to create warmth. A heat pump works somewhat differently than that. All a heat pump's doing is it's moving energy from one location, the outside, to another location, the inside. So in the wintertime, what that means is it's going to be using the refrigeration cycle. And all that it needs to do this is you just need something that's really, really cold outside. So if you have something that's say negative 20 degrees outside and the outside air is 0 degrees, that heat in that 0 degree air is going to get drawn in to that negative 15 degree coil. Now that coil is warmer, it compresses the heck out of that refrigerant, it sends it inside, passes air from indoor unit over that air, and now the house is suddenly comfortable and warm. And that's wildly more efficient than just using electricity like you would if you were heating up toast or blow drying your hair. So air source heat pumps, they just use the refrigeration cycle to move energy from one location to another. And the end result of that is it's a much more efficient use of electricity. So if you're just using it to heat up a piece of toast, you're putting 1 unit of electricity in, you're getting out 1 unit of heat. With a heat pump, say on a 32 degree day, you're putting in 1 unit of energy, but it may be bringing in 3 units of heat into your home. And down to like 0 degrees, it's 1 unit of electricity, 2 units of heat. At 47 degrees, it may be 1 unit of energy and 4 units of heat. So it is true that with heat pumps, even the best cold climate ones today, as the temperature drops, the coefficient of performance drops, its ability to move heat. But it's still always going to be significantly better than just using electricity in a resistant way to be heating up your home. So why are people so excited about air source heat pumps? So we just talked about I just said the coefficient of performance. Let's just see what that looks like compared to a fossil fuel based system. And just so you know, the numbers that I have over here would be for like the very most efficient types of equipment on the market today. So let's just say that you have an oil boiler down in your basement that's 30 years old. That coefficient of performance would be like 0.7. You're putting in 1 gallon of home heating oil, and about 25% of that gallon is going up and out the chimney. There's going to be other percentages of that gallon of home heating oil that doesn't get converted into heat that's distributed into your home. So with the most efficient like oil system today, it's 87% efficient. Most efficient gas system, it'd be 97% efficient. Electric resistance is always going to be 1, but a well-designed air source heat pump. And what I mean by that is like a correctly sized piece of equipment to match the load of the home Over the course of the year, it's about 2.7. So over the course of the year, you're putting in 1 unit of electricity, 2.7 units of heat. Now, one of the things is all of the different fossil fuels are all different commodities and they're all measured in different ways. But I think that this is a good chart to kind of help visualize how much that energy would look like if it was per dollar. So if you look, like a dollar's worth of electric resistance doesn't get you that much. But if you're magnifying it by a factor of 2.7, hey, now we can actually see that that's going to actually give you more heat energy than a gallon of home heating oil at its most efficient state, 87%, or it's going to be more heat energy per dollar than propane. Where things don't win right now in Acton is natural gas is remarkably cheap. It's like, if you look at the price of like how much natural gas was in like 1980, if it like followed inflation, it would be like $7 a therm. But it's right now like $1.45 a therm. So it's like gas prices have just catered since fracking was invented. It's wildly cheap, and electricity prices have just kind of climbed along steadily with inflation. This is true, and we do need to kind of be conscientious about this, that if we are just switching over to air source heat pumps from natural gas, today, there is going to be a bit of an increase in what your annual energy expenditures are if you are moving off of here. Now, I'm happy that people talked about geothermal, and I really did this slide a disservice by not including it. But if you did want to have the lowest operating cost of any system on the market, geothermal today doesn't run at a coefficient of performance of like 2.7. For most cases, it's closer to 4. And at that point, that system is going to be more cost effective than natural gas. The big question with geothermal is just related to the upfront cost of putting that system in. So people are excited about air source heat pumps because they're cost competitive to natural gas in Acton, and they're going to be cheaper to run than all of the other fossil fuel based options. The other reason why people are excited about air source heat pumps is they produce significantly lower emissions, even tied to our grid today. So one of the things that people say, if you did get into the comments section of the Globe article, is like, oh, this is all nonsense. There's so much, the majority of our electricity is coming from natural gas, 70% of our power production is. But when you're tying that natural gas even through all those distribution lines, and you're tying it also onto a grid that has solar, and it has nuclear, and it has hydro, and it's getting cleaner and cleaner by the day, today, it's already about a 40% reduction in emissions compared to burning natural gas. It's significantly better than petroleum. And our state has extremely aggressive targets as far as carbon emissions. So air source heat pumps is the only kind of technology, and ground source heat pumps, that's going to get cleaner and cleaner every single year that you're running it. So as our grid gets cleaner, your heating system gets cleaner, your carbon footprint, if that's something that you want to kind of measure yourself by, improves year after year. And with the town of Acton, they have 100% renewable options to purchase power from. And then the other thing is on-site renewables, which we'll talk about in a little bit. So this is the outstanding question on with the Boston Globe. Can a heat pump replace my existing heating system? And I'm going to answer that, but I think that this is important to highlight. These are both automobiles, and they both can get you where you need to go. They both serve the same general function, point A to point B, but some of the ancillary features are going to be wildly different. Pickup truck, maybe better in the snow, hypothetically. You can carry more stuff in it. Maybe it's a little bit more resilient. Like there's benefits of having a gigantic pickup truck, but there's also tons of benefits of not having that vehicle. One vehicle has the equivalent of 15 miles per gallon, while the other one has the equivalent of 60 miles per gallon. One's quiet, one doesn't pollute, one has all of the latest and greatest features like Wi-Fi, and you can control it with your phone. So I do think that as we are thinking about can an air source heat pump replace my existing system, it's important to think about some of the benefits of your existing system. But in general, Yes. And the reason for why an air source heat pump can replace your system is this fact. Like a BTU, which is a British thermal unit, and it's a unit of heat. It's how much energy is required to raise 1 pound of water, 1 degree Fahrenheit. A BTU is a BTU no matter what it's coming out of. So for example, your home needs 60,000 BTUs, let's say on the coldest day of the year. This furnace on the left-hand side, that could be an 80,000 BTU furnace. So can that heat your home? Yes, it has 80,000 BTUs, that's more than enough. This steam boiler may be 100,000 BTUs. Yes, that's more than enough capacity to heat your home. Forced hot water boiler could be 65,000 BTUs or could be 40,000 BTUs. If it's a 40,000 BTU boiler, it's not going to heat your home on the coldest day of the year. If it's a 70,000 BTU boiler, sure. With heat pumps, it's no different. When you go and look at the manufacturer's specs in the submittals, they have heat pumps that could be 12,000 BTUs, 24,000 BTUs, or 60,000 BTUs. So all a heat pump is, it's just going to be generating heat. It's not a matter of technology, it's a matter of sizing that's going to be really important. So how heat pumps are fundamentally wildly different than I think what a lot of people are used to is how they distribute that energy. And this is going to be true for geothermal as well. It could be wildly different, or it could be pretty much the exact same thing. So with steam, it's going through pipes into radiators. With a traditional furnace, it's going through ductwork into registers, and it's blowing hot air in the home. Most of the time when people are adopting air source heat pumps, it's going to be going through a ductless unit, which what that will be is just going to be a unit that's mounted inside of the ceiling, mounted on the wall or down on the floor. That's going to just be taking the air from that zone, blowing it over a coil and conditioning it, and then blowing it out into that space. So that's really how I see kind of being like a ductless air source heat pump being the equivalent of an electric car, and a pickup truck being the equivalent of a steam system. Like my house, we switched over from steam. It's 100 years old. It's still in really good shape, at least the distribution system is. So it's like, they're just different. There's nothing right nor wrong about any distribution system. It's just something that you do need to kind of figure out whether or not this type of technology will work. And if it doesn't work in a ductless variety, then there is ducted solutions. If we did want to talk briefly about geothermal, we will talk about their distribution system, but most of the time with geothermal, if you have a forced hot air system like a furnace or a central AC, you've already solved kind of the distribution portion of the geothermal system. And that's actually really exciting, because if you already have registers and ductwork in your home, your install cost for geothermal isn't going to be this, it's going to be this, because this was already installed with your previous fossil fuel-based system. All right, so why do people, sorry about this. Why do people love, what do people love about their heat pump? So I'm just going to go over some of the benefits, and some of these are true for only air source, and some are also true for ground source as well. So for air source heat pumps, they are wildly quiet compared to a traditional central AC. So traditional central AC, they're usually in the 70 to 80 decibel range. With an air source heat pump, they're in the 40 to 50 decibel range, if you are kind of thinking about the mini split variety. So they're wildly quiet. You typically need to actually kind of go up to it to see if it's running. So that's really helpful for some of our communities where we work and where there's sound ordinances. The other thing that people love about air source heat pumps as well is they're wildly efficient at cooling. And what I mean by this is, so I have a handful of mini splits in my house. One of my single zone systems has a SEER 30. A traditional window AC would be like, or say a 20-year-old central AC would be like a SEER 8. if my cooling expenditures over the summer was $600 with window ACs at like a SEER or an EAR 8, and I switched it over to a 30, my $600 cooling expenses with just switching technology would drop to about $150. With the multi-zone systems, those are usually closer to like a SEER 18, SEER 20. That would still be cutting your cooling expenditures in half. So this technology, while it may not always win out compared to natural gas, if fuel prices don't change, but they likely will, you may not be winning out on the heating side, but on the cooling side, there's nothing more efficient on the market than heat pumps for cooling. The other thing that people like about heat pumps, and this is so true from all the energy audits that I've run, is a lot of people have comfort issues in their home. Their existing distribution system, there's rooms that are hotter than others, rooms that are colder than others, rooms that they need to add an electric space heater into. With heat pumps, mini splits in particular, one of the nice things about them is you can zone a home. So we have some pictures over here, and one of them is just showing, hey, we finished an attic and we wanted to add conditioning in there. Now we can just, instead of needing to use the existing distribution system, we just put this unit in here. Now it's going to be the most comfortable unit in the house. And I do mean that, like when the rooms that have the mini splits and the comfort level would be considered like not just comfortable, but like delightful. And the next thing that we see on the right-hand slide is a multi-zone system. So with mini splits, there's you can just have one outdoor unit and one indoor unit, or one outdoor unit and multiple heads off of that. And there's some pros and cons of that. But if you do go with that as a design idea, you can actually set each of those zones to be different temperatures, which can be a really nice feature for certain households. What do heat pumps look like? And we're just talking about mini splits over here. There's wall hung units, there's floor mounted units, and there's ceiling cassettes. They also have this other product category called a ducted mini split. And this, I think, is one thing that deserves a lot of attention, because a lot of people may not feel like the interior design, putting a wall hung unit is going to make sense. So what's nice about the ducted units is all that you see inside of the living space is just a register on a wall or in a ceiling or down on a floor. They have units that are very small in capacity that could just be covering one room or two room, or they have other units that have a bit more capacity and they have a strong enough fan where it could be covering an entire floor. And that's what we see in the middle picture over here. So it's the same technology as you would have in the wall hung or floor mounted unit, but it's unencased and you just connect it with ductwork and then you send that conditioned air wherever you want it. They also have this product on the right-hand side, which is really quite exciting because you can go into pretty much any home in Massachusetts. And if they have an existing furnace, you can rip that oil-fired system out or that gas-fired system out, and you can put in a centralized air source heat pump. Cold climate holds 100% of its capacity down to single digits, possibly even down into the negatives. In this unit, it's going to have that same potential level of like a nice thick MERV 13 filter, and it's just sending that conditioned air throughout the entire home. One thing about the unit on the right-hand side, though, is a lot of ductwork, especially in older homes, needs work. So, well, on paper, we could just rip out every single oil and propane and gas-fired furnace and put this unit in. In reality, there may be a bit more to that actual job happening. So it could be that the current ductwork is going to be undersized, it's rusted, it wasn't meant for cooling, so now it needs to be insulated as well. But the product on the right-hand side, I think, is like what's going to be extremely transformational in our market. Because unlike, say, like a geothermal system where you're kind of entering into it with like $20,000 or $30,000 worth of drilling costs, it's like this unit, you just like unpack it, you put in the outdoor unit, you connect it, and it's like you've electrified for $15,000, and now you don't have fossil fuels in your home anymore. So it's really quite exciting. So now I guess we'll get into a little bit of the technical detail and a little bit of the proof. Can a heat pump really be used in our climate? All right. So all of the major manufacturers, they all have products that we would refer to as a cold climate air source heat pump with no capacity drop off. So that means it's a 36,000 BTU unit at 47 degrees. It's still a 36,000 BTU unit down to the single digit. So at no point does it lose its capacity. Mitsubishi makes this product, Fujitsu makes this product, Bosch, LG, Daikin, Trane, Carrier, like every single manufacturer has this type of product ready to go. So just because they have that product, there is a little bit that we do need to think about. So one of the things that we need to think about is whether or not that 36,000 BTU unit, or actually, sorry, let's say that 36,000 BTU unit has enough horsepower, has enough capacity if your home needs 40,000 BTUs. So if we go and look at this system over here, this is a traditional type of heat pump. We would see that at at 12 degrees, this house needs 36,000 BTUs. But this is a heat pump that does have a capacity drop off. So it may be a 36,000 BTU heat pump, but by the time that we kind of reach 22 degrees, the heating load of the home surpasses the heating capacity of the heat pump. So that won't work. But if we're kind of going down and looking at the bottom right-hand side, and we're looking at, instead of a unit that does have a capacity drop off, we're looking at one that doesn't. So this is one from Fujitsu. We would see that this house, you know, down to the design temperature, this was for 12 degrees, it's 36,000 BTUs. This 36,000 BTU unit actually always has more capacity than the house is going to require at its design temperature. So it does fall off a little bit once we kind of get down to the single digits, but it still can be sized that it's always going to be greater than the heating design load. So let's just talk a little bit about contractors and one of the things that will happen as you are looking at this. My messaging is always going to be about getting the system right sized. One of the things, if you are going to be adopting an air source heat pump or even a geothermal system, is it is important to kind of get this design load right. And the other thing is to make sure that you're operating your home, that like a teenage son isn't leaving a window open in January to go when they're going to sleep, because at that point it really could be throwing off how the system is designed and how the equipment is working within the home. So there is something to be kind of aware of, that contractors will be trying to always kind of like add in probably way more capacity than what's needed. And the reason why I'm bringing this up, and we'll be exploring this in just a little bit, is the more BTUs that you need, the more hardware that you need, and the more hardware that you need, the more that this is going to kind of shift this project from being affordable to maybe pushing it into less than affordable. So I do want to just highlight that as a concept. So let's just think really quick about these heat pumps. So cold climate heat pump versus standard heat pump, and whether or not a unit would work for your home. All right, so on the left-hand side, we have a very leaky old farmhouse. It needs 100,000 BTUs when it's say 2 degrees outside. In the middle, we have a post-World War II era Cape. It needs 50,000 BTUs. And on the right-hand side, we have a modern high-performance home. This home only needs 24,000 BTUs on kind of the coldest day of the year. We have two different heat pumps. Let's just think about how they will work. This heat pump, the max that it can do is 30,000 BTUs when it's at 47 degrees, but if we look at what it can do at 5 degrees, it's only 12,000 BTUs. We put this system in any of this home, it's not going to work. Say if we take the heat pump on the right-hand side, which is a cold climate model with no capacity drop-off, it's still not going to work on the farmhouse. It's still not going to work on the Cape, but it would be working in this high-performance home. The thing about this is what's neat with mini splits is all you need to do is just put in 2 outdoor units. Now you have enough horsepower and hardware to power this 50,000 BTU house. So that's one approach. It's like, all right, well, we'll just put in more hardware. And that may not be a bad approach for this house, because this 30,000 BTU unit, the most amount of indoor units that it can handle is 3. So if you're just thinking about this Cape, there's 2 bedrooms on the 2nd floor. There's a bedroom on the 1st floor. There's also going to be a living room, a dining room, and a kitchen. Do 3 indoor units actually make sense if you're going all ductless? And the answer may be no, it may not actually make sense. There's going to be rooms with comfort, where one room is going to be more comfortable than another. So having possibly 2 outdoor units could also be really good, because it could give you a control strategy. In the summer, I'm just going to run the unit that's tied to my upstairs. I'm going to cool that space. All that cool, dry air will drop down onto the 1st floor. In the winter time, I'm just going to, on the more mild days, I'm just going to run the one on the 1st floor and let all that warm, buoyant air rise up. And when you actually do that, you end up running these systems in a very, very efficient way. So that's one way to kind of go about doing it. The other thing that I do hope I implore you all to consider, is there a way through energy efficiency measures to bring that 50,000 BTU home down to 30,000 BTUs? All of the products, the technology, the engineering, the design, all of it's already been done. There's products on the market like continuous exterior wall insulation. There's traditional methods like blowing in more insulation, air sealing the attic, buttoning up the band joists, spray foaming the foundation walls, that could be bringing this 50,000 BTU home down to 30,000 BTUs. So that's something that also should be explored, and I'm happy to explore that with you. Can you get rid of your existing system? Well, we just talked a lot about capacity, and I think the answer is generally yes. You do not need a backup system. So if you have an existing system that's 20 years old or 30 years old and you adopt air source heat pumps, good. That's a really good way to do it, is to go put in the equipment, run it all winter long. And if you do find out that you did, maybe that your contractor may have messed up the sizing, or then it's like the answer is like, yeah, we can just put in another small system and make up the difference. But like a really good way to be kind of transitioning away from your old system for air source heat pumps is like put in the air source heat pumps while your system's working, design it right, and then have the confidence after getting through one winter and actually not turning on your old system, and then you kind of rip everything out. So do know that with air source heat pumps, you can get rid of your existing system. The tricky thing when we are thinking about this technology is related to the sizing of the outdoor units and the number of indoor units that you can have on it. That's really kind of, as I've had, I don't know, a few hundred consultations about this, that's kind of the biggest issue, but it's somewhat easy to deal with because you can always switch one of those ductless units to a ducted unit. So say for that Cape that we had earlier, it's like you could put a ducted unit inside of the 2nd floor and duct it to both of the bedrooms, and then you just have 2 ductless units on the 1st floor, and now just having 3 units can make sense. How much do air source heat pumps cost? And I do want to just highlight, as we look at these next slides, this house is relatively small. It's like going to be like 2 bedrooms and an open concept. So a lot of homes, the cost of this project, if you have 4 bedrooms, it's going to be likely double this. But I do want to kind of use these slides to kind of set some expectations of whether or not this will be an option for you and your family. So One option of adopting an air source heat pump is the same way you would be heating your home with a wood stove or a pellet stove. And that works for some households. So you just have one centralized heat emitter, and you just let that heat go where it's going to want to go. And I can tell you that the living room in this house, the dining room in this house, the kitchen in this house is going to be delightful as far as how the comfort feels. But say the 2 bedrooms on the end, they'll probably be comfortable. But say if it's 5 degrees outside or -5 degrees outside, probably not so much. So do know that, like, some people who, this may be perfectly fine. For other people, it may not be. But if you size this air source heat pump, this one air source heat pump, to that heat load of the entire floor, do know that it's going to work. It just may not meet all of your comfort expectations. This is what a lot of contractors, when they're going and talking to people about it, try and do, is they go a little bit crazy with the number of indoor units that they're trying to put in. So they're putting one in each of the bedrooms, they're going to put one in the common area, one in the dining area. But if we see, it's like the cost of this project just went from $5,000 to $20,000. So the problem number one, if we were talking about a 2-story home, now we're talking about $40,000 for HVAC equipment, which moves things to unaffordable for a lot of families. The other problem is the heat load of this space was probably closer to how much capacity one unit would have given us. So now the total amount of horsepower of all of this equipment is probably 2x or 3x what this space actually needs. This is an approach that I always implore people to do, and it's trying to use a combination of ductless equipment to likely keep down costs and ducted equipment to distribute that heat evenly. So it doesn't really save any money, but if you're wanting to get your heat pump system working most efficiently, having a single ductless unit in a common area and then having a ducted unit hitting all of those small bedrooms is going to work really well. And the reason for this is, like, most bedrooms, let's say it's 200 square feet. The heat load of that space at the coldest day of the year, it's probably 4,000 BTUs. The smallest ductless piece of equipment is 6,000 BTUs. So it's like over a third oversized on the coldest day of the year. Most days of the year are not the coldest day of the year, so it's always going to be wildly oversized. So that's why we like having the ducted units, because then you can really do a perfect job with matching the capacity of the load of the rooms with the capacity of the units. This is the approach that I took for my own home. So I just went and first I had a budget. And then I made the system work according to my budget and according to matching the heat load. So over here, it's like we have one unit on the left-hand side, and that's going to be conditioning the large area. It's also going to be helping to blow into the bedroom. But then there's another unit that's just dumping into the bedroom down here, and that heat's also going to be migrating out. So usually when you are thinking about the equipment, it is going to be that, like, I don't like the word compromises. It's just different than what I think we're used to with having an emitter in each and every room. But I have no concerns with my own setup because I lived through my previous winter having steam heat and having it so noisy and so noisy that it literally would wake us up at night, and we had to turn off the radiator in the master bedroom. So we didn't have heat in that room, but I weatherized, I replaced my windows, and it turned out that I didn't need a radiator in my master bedroom. And in my daughter's room, she had an electric resistant space heater. We didn't turn it on all winter. And it turns out we didn't need to turn it on all winter. So there is something with, like, when we are thinking about our homes and what we've traditionally done, they've traditionally always had an emitter, whether that's a register or a radiator or a baseboard in each and every room. Because for a lot of homes when they were made, there wasn't any insulation in the wall. There were single pane windows. Like, every single room needed an emitter. But as we insulate our walls, we button up the foundation so air's not just leaking in, and we insulate and air seal our ceiling, all of that energy that's inside of the room stays inside of the room. And that's one of the huge things that make air source heat pumps like market ready and good for our region today, because people have taken advantage of mass save, and building codes have also made homes more efficient. Are they affordable? So we just kind of looked and saw some pricing. So, and I didn't highlight on the last slide, for my own project, I got 6 indoor units, 3 outdoor units. My total out of pocket before incentives was $21,000. So, you know, I shopped around. I didn't have any special, like, we run heat pump programs, insider information. That's how much my project costs. And I do think that I'm happy to work with you in trying to find a contractor to find a project that is affordable, if that is, if the cost is kind of the biggest issue. As far as affordability, I want to talk about this because it did talk, some of the Boston Globe article did mention this too. It's a weird spot, September of 2021. The Mass Clean Energy Center's air source heat pump program has concluded for the year. The DOER, which runs the Alternative Energy Certificate Program, the price of the energy certificates is completely cratered. The Mass Save program is doing next to nothing for natural gas customers to adopt these technology. What Mass Save is doing is they're making them very affordable for oil and propane and electric resistance customers. So those customers, it's like, I see no reason of waiting. In 2022, things are going to be getting better. That's pretty much a fact. So do stay tuned. And it is good if you are thinking about adopting air source heat pumps or ground source heat pumps and you're a natural gas customer, get started today. These things do take a long time, from kind of like meeting with contractors to getting the design to signing the contract. So there's no need to pause. If I was a gas customer, I wouldn't be signing a contract necessarily today. But going back to like this question of affordability, one thing I did really want to highlight that is hugely important for the adoption of this technology is the Mass Save Heat Loan. So for oil, gas, propane customers, it's a 0% interest loan with a 7-year term for adopting this technology. So for my own project, I have a $231 bill a month for the next 7 years. And that was probably one of the biggest drivers why I was able to do this. So do know that if you are thinking about this, make sure you have an energy audit. You need to get one of those to get the heat loan, but it really will be huge and for a lot of households for making this affordable. The other thing, if you are building new construction or you're completely gutting a job, Mass Save also has a renovations and additions program, which is run by ICF, in that they're another kind of like stakeholder in the state's energy efficiency stuff. So going back to Andrea and like what we're talking about, and I think even on some of the notes, like what is the impact of adopting air source heat pumps today? People are really excited about this technology because of its climate impact. And I have all of the math over here. This slide's not all that interesting, but just know that the numbers we're about to see is for the average home in Massachusetts. And I did want to just kind of show you guys a few things. So this teal color, this is how much this equipment's going to cost over the course of 20 years if fuel prices aren't going to change, but they likely will. So if we do go and look, we do see that, like, you know, with a oil-fired boiler, it'd be about $35,000. You look at a well-designed air source heat pump, it may be about $30,000. So it's like their savings, it's not huge. But if we do go and look at this white bar over here, that's how many tons of metric tons of carbon would be released over the course of 20 years. It's a difference between 50 versus with home heating oil. I gotta just slide this away, where it's over 100. So it's like, that's one of the reasons that people are very, very excited about this. And same thing with natural gas. It's just a huge drop. But this is kind of really just part one of this slide. So let's just hang tight. Because in Massachusetts, with your electric company, they support retail net metering. And what retail net metering means is you go and sell a kilowatt hour of electricity to them, they need to sell it right back to you at the same price. And when the other thing, I guess that's not shown, is the price of on-site renewables, i.e. solar PV, it's just crashing right down in a really good way. So if we did go and we look at how much that cost, how much a watt cost in Massachusetts in 2008, it was $8 a watt. And just in 2018, it was statewide average $4 a watt. With my own solar project, I went with Tesla. I'm happy to talk to you about the pros and cons. But one of the pros is they're selling solar at $2 per watt. Now, one thing to know is with solar, another good resource is energysage.com. If you go punch in your address, they'll kind of do a rudimentary design, shop it around to all the different solar installers, local solar installers, and all those local solar installers will then be able to provide a quote to you. So it's a really, really good resource for shopping for on-site solar. So I'm gonna hop back to that slide in a second. So let's now go look at these numbers again. So say that you're able to size your heat pump, size your solar array to meet your heat pump's annual capacity. This is what those numbers look like at, and I have this set at the equivalent of $4 a watt here. So it is on the higher side than the statewide average. At this point, we go and we look at a well-designed or even a poorly designed air source heat pump. No emissions. We look at how much that system costs over the lifespan of the solar. So instead of paying per kilowatt hour, now you're just paying for the solar array. And if we go and we look at that, and this is also before tax incentives, and that's why I'm going to hop back to the previous slide, we're going to see that the cost of how much solar you're going to need to buy to power this system is going to be way less on a well-designed air source heat pump than it would be with natural gas. So with air source heat pumps today, the operating cost can be less than even natural gas. The carbon impact of could be zero. Your on-site greenhouse gas emissions. And part of the reason for all of this, why solar makes so much sense in Massachusetts, retail net metering, the SMART program from the DOER. There's a state tax credit of $1,000, but the federal tax credit is now 26%. So if you're a $10,000 project, you get $2,600 back on your taxes. This got extended as part of kind of the economic recovery from COVID. This got extended all the way into the end of 2022, and then it should be stepping down to 22% and then 18%, I believe. So do know if you are thinking about air source heat pumps or ground source heat pumps, you should be thinking about on-site renewables as well. I'm like, I got to go a lot faster. Just make sure that as you are talking to contractors about air source or ground source heat pumps, you are talking to them about heat load calculations, what software they use for it. It's hugely important in the successful adoption of this technology. If you are just trying to think rudimentary about like what this equipment's going to look like, take your square footage of your house, multiply it by 20, and that's likely going to be somewhere in the ballpark of an appropriately sized system. So if you did want to kind of start to figure out like, well, how many BTUs am I going to need? Just take your square footage, multiply it by 20. If you got a very leaky home, multiply it by 24. If you have a very tight home, multiply it by 16. And that I think would be a helpful number to kind of start thinking about equipment. I already talked briefly about my own house, but I do want to just talk about this. When all's said and done with my house, the total amount of improvements that I made was about $30,000 in like energy efficiency improvements. My electrical cost, after all said and done, I'm planning on budgeting about $1,500 for my heating this upcoming winter. If I didn't do anything, and I kept just kind of going off of my steam heat, it'd be about $2,300. So let's just think about this. I spent $30,000. I'm going to be saving less than $1,000. And it's like a question could be asked. It's like, why? It's like because heat pumps, like any high efficiency system, the lifespan is going to be like 20 years. So it's like, is this all these improvements going to be paying for itself? And I think the answer is no. Like the math may not work out if fuel prices stay the same. But I think it's really important as we are thinking about this to start thinking about some of the ancillary benefits. And they're all real. Like this is easy for me to say. My house is way quieter. I'm like somewhat off of a busy street. A lot of that has to do with the insulation, the windows, but I'm happy to have heat again in the master bedroom and centrally or a cooling solution in the master bedroom that's very, very quiet. My house is efficient. It's super easy to use things and adjust things with windows. I can lift them up with a finger when I want the temperature to be a degree warmer or a degree colder. It's just like pushing the volume up or volume down button on the TV remote. I've lowered my carbon impact. I now have on-site energy production. I'm a step away from having a battery, and that's going to give me a ton of resiliency in case there is ever a severe storm. And in Central Mass, we've had plenty. So there's like tons of reasons to do it. Oh, and I guess the other thing, it's like I put in a $30,000 investment. When someone steps into my home, they're not looking at a heating system of 100 years ago. They're really seeing kind of like the heating and cooling system of the future. So it's like, I do think that as you are thinking about this, you may need to kind of put that question like, oh, well, is it going to pay for itself? It's totally important, but do know that there's going to be a lot of other benefits that you do get with adopting these type of technologies of decarbonize that come with decarbonizing that you don't get with just putting in a new boiler. So we're finally on to ground source heat pumps. So pretty much everything that I said about air source heat pumps is true, but there's one huge difference. So, and I'll just give you guys all the reasons why ground source heat pump people are ground source heat pump people and not air source heat pump people. The fact is that let's say that it's 0 degrees outside and you have that negative 15-degree coil, it's only pulling in a delta of 15. But say that coil was underground, now the delta is going to be like 65. There's going to be like so much more energy for that coil to absorb and bring into the house, pressurize, compress, get it nice and hot, and then send your air over it. So it's, you know, hypothetically like wildly more efficient. So in some circumstances, maybe a ground source heat pump, if the pumping costs were perfect, could be a COP of 4 or 5. But typically in actuality, it is kind of closer to a COP of 4. The other big thing that people really do love about ground source versus air source, there's so much more flexibility in mechanical system design. So one thing that people like about geothermal is you can do it through air vents, and that's great for cooling, but there's other ways that people do like to heat. There's nothing wrong with heating with a radiator. There's nothing wrong with heating through a radiant floor. And ground source heat pumps have the ability to also be heating through hydronics. That same ground source heat pump can also easily tie into heating up your domestic hot water, which is 30%, 20% on a high efficiency home, 50% of the home's total carbon impact. So it's really nice to have one heat pump to do heating for the conditioned space as well as heating for domestic hot water. The biggest reason I think why people are so excited about geothermal versus air source heat pumps is this is what the side of a house looks like that has air source heat pumps. They are always contraptions on the side of the house. And I will say with traditional fossil fuels, there's contraptions on the side of the house too. Gas meter, oil pipes, exhaust vents. So it's not like fossil fuels are an equivalent over here, but when you are just looking at like the picture on the left and the picture on the right, you know, it's like, it's nice not having any outdoor equipment. And the big thing that I think about as someone who does care about energy efficiency as well as resiliency is like our weather is getting weirder. Polar vortexes do happen. Snowpocalypses do happen. Ice storms do happen. So there is a lot of peace of mind with knowing that no matter what Mother Nature throws at it, you're not needing to go out at 2 a.m. or 1 a.m. to shovel off or to, you know, like the outdoor unit. You do have kind of a lot of peace of mind with a ground source heat pump system. So higher efficiency, no outdoor unit. I think that's really kind of what makes a ground source a no-brainer. But we do need to always just deal with the fact that, say, with those air source heat pump projects, you know, it's like for a fully ducted, you know, let's say like a fully ducting a house with a air source heat pump project, it could be like $40,000, $50,000. With a ground source heat pump program, you put on $30,000 of drilling cost on top of that. Now it's, you know, now it's kind of moved, you know, now it's really kind of moved in a different direction. But it is important to know with ground source heat pumps, there's the 26% federal tax credit, and Mass Save is helping out with $2,000 per ton, so 12,000 BTUs for oil, gas, and propane customers. Last section is going to go really, really quick. Don't forget about domestic hot water. It can be a huge percentage of people's energy load, carbon, the amount of carbon. There's heat pump hot water heaters, two different types. One's a packaged unit. It works the exact same way as a refrigerator, but in reverse in your basement. So your refrigerator takes heat from inside the box and it dumps it outside the box into your kitchen. Heat pump hot water heater, the box is now your basement. It takes the heat from that box and the moisture from that box, and it dumps it into your domestic hot water, and it heats it really well. They also do make split level heat pump hot water heaters. Another option is solar hot water as well. This is great when solar PV is not an option, because you only need 2 or 3 panels up on your roof, and that's just collecting all of that radiant energy from the sun, sending it into your domestic hot water, and it displaces about 70% of your total energy cost related with domestic hot water. Versus packaged heat pump hot water heater, where it'd be closer to, that would be closer to having a coefficient of performance of 2. So that would be like a 50% reduction. So, and with the split level heat pump hot water, that would be a COP of closer to 3. So there is kind of some varying efficiencies on all of that equipment. Where should you begin? So on our website, which once you go to our website and you go to the Town of Acton's page, the thing that happens when you go on the page is a pop-up happens and it says you should start here. If you click that button, that will send you to a link straight to my Google Calendar through an app where you can book some time and talk to me. And I can kind of share everything that I did today, but how that actually works or could be implemented in your home. So I'm more than happy to spend as much time as required to talk to you about any of these clean heating technologies. And one of the things that I will also say, usually these are not, you know, one consultation, we figure it all out. It's like, let's figure out where to start and let's come back after meeting with contractors. We'll regroup, we'll review all the proposals, take it from there. This is going to be obvious, but I care deeply about energy efficiency. We're working with All-In Energy to help people kind of get coordinated with a home performance contractor in the Mass Save program to make sure that you can get the energy audit, you can get the heat load, you can get the heat load of your home buttoned way down and make these systems more affordable with ideally like kind of buying less hardware. Okay, and then the last thing with locating contractors, I'm more than happy to help you out with it. We have a participating contractor list for the city of Acton, but you know, social media is a great place. And if you, any of the manufacturers, if you punch in your zip code, they'll help you out with finding a local contractor in your area. All right. How about Andrea, do you want to take it from here?
Yeah.
Sorry, I went over on time.
Oh, no worries. I think you deserve a little break right now. Thank you so much, Mike. So next steps, we will continue exploring solutions and offerings to overcome barriers. Mike mentioned affordability, and that's a big barrier that we're constantly looking at ways to overcome those. And there's a lot of interesting opportunities for partnerships or working closely with the town and figuring out what sort of funding we have to tap into to make these transitions easier. In addition, I mentioned the climate action plan open house. You can drop in at any moment. You don't have to be there for the full time, but it's from 2 to 4 on Saturday, October 16th. And I did say I was going to post the link, so I'll get that link out and post it on the chat. We will have an information table with information on Abode and signing up for that consultation with Mike, and flyers with additional information at that workshop. And with that, I think we'll leave it up to Q&A. Shall we promote everyone to panelist?
Sure, and hopefully my Wi-Fi is stabilized here, but I can take a look at promoting everyone. So just so everyone's aware, can you hear me okay? I'm getting unstable notes.
Oh, sorry, go ahead. And while you do that, one other quick note, I did see Deborah made a comment about APC Green. So Acton Power Choice Green, that's the 100% renewable energy option that everyone has in Acton, residents and businesses. And so I'll post a website to that. So in addition to solar, which is wonderful, there's also the option for people to go net zero quite easily by opting up through the aggregation program. And thank you to Mike. I'm surprised you didn't lose your voice, not because you spoke for too long, but because you just have so many tidbits and information to share.
I say this mostly in jest, but when the webinar recording goes out, it will be on YouTube, and you do have the option of slowing down the playback speed. So for those last few slides there, you may want to take it at 75%.
I do see, well, people are, I guess, gathering themselves. I was just going through the comments, and it says, one of them that I just saw was, why does the whole home central unit ducted system say dual fuel in your slide? So there's both. So for a variety of reasons, people may be uncomfortable, and it may be that their installer's uncomfortable or their ductwork is wildly undersized. And so they do make, like all of the American manufacturers, so the Carriers, Trains, Amanas, Lennoxes of the world, they make a heat pump that sits on top of a traditional oil or gas or propane fired furnace. This may be ideal for some people that do have undersized ductwork, because the coil of the heat pump is going to be like 120-degree refrigerant, versus a coil of a fossil fuel-based system could be at 350 degrees at the heat exchanger. So for the air source heat pump to work in the middle of the winter, coldest day of the year, it's going to need to send a lot of air from the house over that 120-degree coil to go send it up into the rooms. Versus a fossil fuel system, it can send a little bit of air over that coil, and it's going to pick up a huge amount of energy, and then it's going to dump into the rooms. So one of the things that could possibly happen, and why I have dual fuel on there, whether I meant to or not, is that for some people, just the amount of noise that kind of just dumping in a high efficiency heat pump central air indoor unit may not be the right solution for that household. So do know that there's like a wide variety of reasons why like people may not be ready to abandon fossil fuels. Their home's not appropriate for it. But we had an employee recently did a survey about all of the people who we've consulted with about air source heat pumps, and I was shocked to see this. 80% of the people that we actually spoke with and learned about their home and learned about their goals, they've either installed an air source heat pump or planning on installing it within the next year. So it is like it is really a good technology for the vast majority of those households. One of the things that's not said on that those numbers is it may really be that it's like the air source heat pump is going to be displacing a large amount of fossil fuels, but it may not be removing them from the home. So every home is different. It's super nuanced with kind of like what is the right approach or the best approach, but I'm happy to work with you on it.
Deborah did make a note at one point, or I don't know if you want to say it, Deborah, but about the natural gas prices predicted to rise over time. And I know, Mike, you sort of alluded to that without necessarily predicting the future, but and then Arnab, I'm not sure if I'm saying your name right. Feel free to correct me, but you said we have, oh, and I think there's still people left to be panelists. Oh,
yeah,
they just haven't accepted.
So some folks declined. If there is anyone else that I missed that would like to be a panelist, if you could just raise your hand using the raise hand feature, I will get you.
Okay, awesome, thank you. They said we have baseboard water heating and a separate central cooling system with ducts. What should be our most optimal option to move to a heat pump based solution?
Yeah, so usually when people have that set up, oftentimes the AC is up in the attic and that's dropping cool, dense air down. And sometimes the ductwork is running through a closet on the first floor. But usually a big problem is that it usually has a central return that's on the second floor, which does a great job for cooling. But if you are trying to heat with those ducts, one of the things that will happen is you're like dumping the heat down, but it's already warm and buoyant. So it's already wanting to rise up. And then the return is also sucking that air further up. So those types of homes, I guess the good news is you have probably what I would think of as half the distribution all set. So I think a good solution could be like putting a centralized heat pump to replace the central AC. And then on the first floor, it may be adding a ductless unit or 2 ductless units or a ducted unit down in the basement, and kind of disconnecting the ductwork that would normally be doing the first floor from that central unit down in the attic. But right now, if you have existing baseboards, so like forced hot water, even with a geothermal system, like the most efficient heat pump, it doesn't get the water to 180 degrees, which is what those baseboards are designed for. So do know that like if you have baseboards or if you have column radiators, it's likely not going to be able to be integrated into a air to water heat pump or a geothermal heat pump. That portion of the equation is likely going to be is likely not going to be solved for many years. There's some physics and thermodynamics that's preventing it. There's 1,000 different ways that they could just like add a bunch of electric resistance to make it work, but I wouldn't be thinking that it'd be like a heat pump at that point.
And Deborah's raising her hand.
Hi, thank you. Thanks so much for doing this. And I just want to do a shout out to the town for providing Abode services, these consult services to us. It's awesome. Also, one other thing before I actually ask my question, which is that the town I know is working on how to distribute some ARPA funds that are heading its way. And, you know, one of the concerns I have as someone who's, you know, trying to work on this stuff and include equity in the calculations across the town is perhaps as people fill out the ARPA survey, they could talk about the importance of making upgrades, efficiency upgrades, and who knows what else equitable across the population. So you might advocate for that in your responses to that ARPA survey. And maybe somebody has the URL for that and can throw it into the chat. I don't right this second. But my real question is this, Mike, I have an appointment with you in a week and a half, but you gave us that little down and dirty equation about take your square footage and multiply by 20 or 24, probably in the case of my house. And that will give you a rough sense of the size of the system you're going to need. However, in my particular case, I'm really eager to like do this little math. In my particular case, our house is like a 4-level, multi-level house.
Yeah.
How does that affect this equation?
Yeah, it's a good question. I do still think that you're more than welcome to go and use that formula, but do know that as we are thinking, say during the consultation, as we are thinking about, say, that 60,000 BTUs, if I'm just going to say it's 60,000 BTUs, I would say on the first floor, it's probably going to be like 25, and then on the top floor, it's going to be 15-ish, and then take the middle 2 floors and half. So it's kind of always the cold air is always infiltrating down low. You have the basement. So that's typically when you actually go and model the houses, doing an accurate manual J heat load calculation on kind of how it all plays out. But there's some like somewhat consumer, like if you're nerdy about this stuff, there's like a really friendly software called Cool Calc, where you can actually go and you can do a Google map trace of the footprint of the home. You can say what's below it, what's in the walls, what's above each floor, and that can actually spit out a pretty good report as far as how to start thinking about the individual zones or the individual rooms.
Okay. And you did say Cool Calc, like CALC?
Yep, you got it.
Okay, thank you.
Yeah, and you can go through you can use the full software at no cost. It's just HVAC contractors who want to get the actual report. They download it, but it's like super cheap. It's like $5. But if I was an HVAC contractor myself and I was ripping out someone's existing system and putting in heat pumps, I would be using more robust software than that. But I think that's if you have an existing system in place, you feel like you're doing good due diligence, you're trying to imagine equipment, I think that it's a really good way to go.
Thank you. And thank you, Andrea, for throwing those URLs up.
Yeah, the ARPA fund survey that Deborah mentioned is in the chat, and the Cool Calc link. Any other comments? I know, Bryce, you said you would
Karen,
love to.
I think Karen is.
Sorry about that. I didn't see the hand raised. Thank you, Ryan.
Yeah, I wanted to ask, I mean, Andrea, thank you to you and the town for doing this. This is so exciting. And the technology is really fascinating. I do have one concern because my mom lived in a building that was heated with like big air source heat units. It was 26 apartments for seniors. And they had some serious leaks of the refrigerant. And I've heard other stories where that's happened. And I mean, is the technology getting better so that, that doesn't happen so often? Or are the contractors, are people gradually getting better trained to see the clues when there are problems, in the pressurization or whatever, so that they know that there's a leak?
Yeah, so that's a super great question. And we've thought deep down, we've like searched our souls with whether or not we should be, promoting this technology that's currently using a refrigerant with such high global warming potential. I do think that this is one of the resources that manufacturers do have, is they do have contractors that's gone through the manufacturer's training. And part of this is nitrogen testing the system, making sure that there's no leaks before a single drop of refrigerant going in. So with refrigerant leaks, if they install it correctly, the equipment doesn't leak any more than your refrigerator would leak refrigerant. Like 99% of the leakage that occurs with these systems is during install and doing improper commissioning of the equipment. And I do think that as you are meeting with contractors, that would be a question that I would be asking them. Do you pressurize the systems with nitrogen before putting any refrigerant in? Will you show me that you are doing it, before you're putting any refrigerant in? And one of the things that I do provide at the end of every consultation, I send a follow-up email. And one of the resources is from NEEP, which is the Northeast Energy Efficiency Partnership. And they have a document called the Air Source Heat Pump Consumer Buying Guide. And one of the things is like questions that you should be asking installers. So there's questions like what you just brought up, Karen, that's totally worth a question worth asking your installers, but there's a handful of others too. So yeah, it's totally a concern, but at the same time with traditional systems, it's not global warming potential with burning fossil fuels. It's global warming. So I do think that that's really important to be keeping in mind. It's like if it is a catastrophic install and does go out into the atmosphere, I don't know. Like I know that I've seen the math, but that's probably for most homes like the equivalent of 8 years of burning natural gas. We don't want to see it happen, but it's like we do need to be doing something differently. And do know that like one of the things that I had on a slide that I didn't touch about with the split heat pump hot water heater. So that was the hot water heater that had like the mini split looking outdoor unit. that's using CO2 as a refrigerant, which is a global warming potential of 1. And that's really exciting. And I am really excited about the future of these products with the refrigerant being better. But it's the best that we have right now, and it is a solution, and it can be, completely contained the same way, your refrigerator's not leaking refrigerant.
I think someone asked a really good question, John Perkins. He says, without solar, how can heat pump lower emissions if you're using electricity to run it? And then Deborah already got to it. So she's describing the various options through Acton Power Choice Green. So there's the various mixes and energy supply, and you can see more information. Oops, I sent 2 links, but you can, if you click on it, it should take you there. But the 100% renewable energy option, if you're on that and you have air source heat pumps and your home is fully electric, then you will have a net zero home. So that's an option to have a net zero home without installing solar. And I don't know, Mike, if you want to add anything else to that.
Yeah, well, I guess it just goes back with our grid, and we can pull up ISO New England right now, but there is renewables on our grid right now. There is nuclear on our grid right now. So it's not, we're not burning 100% natural gas to be generating it. And so it's like, yes, you have this full unit of energy at the plant. And by the time it does get to your home, it's probably lost about 70% of its total capacity, but you are pairing that with all of the renewables on the grid, or the carbon non-carbon producing generation on the grid, plus the coefficient of performance of the air source heat pump. And the math does work out. It's about 40% less emissions per BTU than natural gas, and it's getting cleaner by the day. And especially with Massachusetts, where it does seem like offshore wind is going to become a reality, more and more solar is being installed every single day. It's like very clear how our grid is going to be getting significantly cleaner.
Yeah. And Deborah did touch on the renewable portfolio standard. So the amount of renewable in our mix is going to be increasing in the next decade. And then you also have the option to increase it yourself sooner if you'd like. And then I see Susan has a hand raised. We can't hear you.
Okay, hear me now?
Yep.
Okay. So I'm on the building committee, energy manager for St. Matthew's United Methodist Church, and we have like a 30+ high ceiling in our sanctuary. So how would heat pumps work in that environment?
Back to my slide with like a BTU is a BTU is a BTU.
Okay.
That still very much holds true. You're likely going to be looking at a different type of a heat pump. You'd likely be looking at like a VRF, a variable refrigerant flow type of system, where it's a much bigger outdoor unit. And there's actually more configurations of indoor units. And they actually do some cool things where instead of like one unit could be calling for heating, one unit could be calling for cooling, potentially. And instead of like dumping some heat outside and picking up some heat outside to move it to the other unit, it just sends the energy from one indoor heat pump to another indoor heat pump. So it's really exciting. One of the things that's true with these larger buildings is, I don't know what the existing distribution system is, but it's like you may need just like one massive boiler to heat this entire building. But if you are kind of getting into like trying to heat a massive sanctuary with heat pumps, that is wildly weird loads. Like no one uses the building for 6 days of the week, for maybe like 6 days a week. But then for like 1 hour, like all the, doors are completely open. Then there's 200 people in there. Each of those is offering up like 200 BTUs per hour. And it's like, are you heating it or are you cooling it? So it is really tricky. So with those types of projects, like I really, I'm not a mechanical engineer, but that's who you really should be kind of coordinating with. And I'm happy to reach out to my network to try to help find someone who kind of does have the expertise with finding that, the right piece of equipment for those really wacky loads, and seeing if there is a way to kind of move that building off of fossil fuels. But houses of worship are super tricky, but people are doing it. Congregations are doing it. So it will require a bit more thought than I think on a lot of just kind of residential projects where it's super, I think in my mind, it's super straightforward.
Okay, well, we have programmable thermostats that really help us monitor, our heat.
Yeah.
And also we do have in our lower area, a small office area that's sort of like 4 bedrooms combined. Okay. So maybe we'll tackle that space first.
Yeah. And one of the things too, it could be that you're like turning on, you're just like, there's an office admin or there's someone working in the office, and it's like now you're needing to heat the whole sanctuary because this one zone's called for. So yeah, it could be a part of, it's like, well, we can decarbonize this portion of the building. And that's totally a really good strategy. And one thing I guess too, with just in general with like air source heat pumps and specifically like houses of worship, is a lot of them were never built with any sort of cooling mechanisms. I don't know if that's true for your congregation, but that I think is like one of the big benefits is that there could be cooling as well as heating as part of the equation.
Yeah, our Sunday summer air conditioning system is opening the windows. So we would like that.
Yeah.
And Karen?
Yeah, Mike, you mentioned solar batteries in terms of resilience. Yeah. I mean, could you say a little bit more about running air source heat pumps off of solar batteries?
Oh, yeah, it's less than favorable. Yeah, you'll chew through them. You would end up chewing through them really quick. So if you are, so as far as resiliency goes, for my own home, when I'm thinking about resiliency and batteries, I'm not thinking about running my heat pumps for days or weeks on end. You can still run it, but it'd likely be chewing through it rather quickly. So I do think as far as the resiliency portion of it, the batteries is kind of a separate situation. And that's one of the going back to like the Tesla and the pickup truck, I can run my steam system off of a solar battery. So it's like, that could be potentially one of the ancillary benefits of like a traditional fossil fuel-based system. But say, would you be able to run a oil-fired furnace off of the solar battery? The answer is a lot less than a steam system, but a lot more than a heat pump. So it's like they all have their pros and cons. But if we are kind of thinking about like, if we are out of power for a week, like, do the heat pumps still play a part in that? I wouldn't be thinking about it off of batteries. With today's technology and pricing, and the pricing of these are likely going to be crashing, and especially, let me rethink all of this, because say you got 2 electric vehicles and you have 2 batteries in your basement, and that's likely going to be a reality probably in a decade. It's like, now we may be able to be running these heat pumps for, overnight until the sun starts shining again. So I'll need to be thinking a little bit more, but right now, today, 2021, I wouldn't be thinking about running heat pumps off of a Tesla Powerwall or any of their competitors.
Oops. I don't have another question right now.
You'll just keep your hand raised. Deborah also says, is the leaking of coolant that's happened related to the media of the conduits, e.g. PVC versus something else? She means,
so normally with the refrigerant leaking out of the system, it's usually at the fitting. So where kind of the refrigerant line is meeting the connection to the actual mini split or the outdoor unit. That's usually where it happens. There was recently a bit of a horror story of one type of pipe insulation that a lot of installers were not following the manufacturer's recommendation of taping all the seams. Moisture got in, it corroded the type of like polyethylene urethane, and then that was putting like pinhole cracks into the refrigerant line, and that did cause a lot of leaks. It seems like the whole industry has moved past it and is aware of it. So yeah, it's like anything in life, there's a handful of things that can go wrong. But yeah, it's usually that they don't, this is usually like the owner, operator, sole proprietor type of shops where, you know, it's like they can do anything. They can remodel a kitchen, they can put in a new bathroom, they can put in a gas furnace. That's like, yeah, I can do a mini split. And those are usually the types of shops that do have more problems related with install. The contractors that you'd find on like Mitsubishi's website, Fujitsu's website, the certified contractors, they're like, these contractors, all that they're doing is like putting in these systems and they got the process down and they don't want callbacks. That's like so true, is like they want to kind of do it and not ever hear from you again and just collect the final, you know, final 1/3 or 1/2 of the job. So yeah, those types of shops are the ones that do have kind of they know the equipment, they have a process, they train their guys up, and that's all that they're doing.
Can I do a quick follow-up?
Yep.
It occurs to me now, and I have never thought about this before, weirdly, is there any kind of maintenance that's required, you know, barring refrigerant leakage or whatever, but what do these systems need?
Yeah, there's kind of two thoughts that I have on this. So at the end of the day, it's the same exact technology as a refrigerator. And does your refrigerator require any maintenance? The answer is no, it's just kind of a refrigerator. When it stops working, you know, maybe you'll call an appliance repair person, maybe not. But at the other side, we are in New England. We have 4 seasons. We have every single type of bug in the world. You know, we got ants, we got bees, we got rodents, we got squirrels, we got birds. So it is like the outdoor unit is exposed to the elements, it is exposed to pests. So it is, I think, at the same time important to kind of get a professional out there to make sure that everything's doing what it should be, that the line sets, the insulation on it isn't being worn down by the sun, none of the zip ties have broken down from UV light, like there's not any nest forming inside of it. There's moisture on the indoor unit in cooling mode, there's moisture on the outdoor unit. So it could be, you know, when moisture evaporates, it's leaving behind, like if the moisture inside of the unit gets winds passing over it, dirt's getting on it, it's evaporating, all that dirt's getting left. So like, yeah, it does need some maintenance. So the manufacturers all say 1 year. I think it's probably closer to 2, but I think it's kind of, you know, what's in your budget. Like if you're the type of person who brings their car to the dealership for like routine maintenance, then I'd say, yeah, I get it done every year. If you do kind of are more like, I'm going to go, you know, I have my guy down the corner, then like maybe you're more of a, you know, do it every 2 years. But the indoor units, the filter on those should be kept close eye on. And it really does depend on the household. So if it's in the kitchen, there's going to be a lot of like grease that's in there. That one's going to get gummed up. You have a bunch of pets, that filter is going to get a lot dirtier if you don't have pets. And it is really important for that unit, for that filter to stay clean, to get the correct airflow, and the correct airflow is important for kind of moving the moisture out of the unit too. So.
Okay. So a sort of semi-annual inspection outside.
Yeah, I think a responsible homeowner could get an eye on it, like maybe get have the service guy out the first year and ask, stand behind him or her and ask them a lot of questions as they're doing what they're doing. And then you can maybe take it from there and skip a year.
Okay.
yeah, you should get a professional to keep an eye on it. But yeah, it really there's nothing about the technology like oil. If you're burning oil, there's a ton of soot and crud that gets in the burner and inside of the boiler that physically needs to get scrubbed out and vacuumed. Mini splits or air source heat pumps, nothing like that.
Thank you all. Yep.
Well, yeah, if that's everything, yeah, I do implore everyone, check out the website, book some time for their own home. I think sanctuaries might be slightly outside of our scope of work, but more than happy to talk about the specific
Okay,
project.
thank you.
Yeah, just
Appreciate that.
put in your home address. That's a joke. But yeah, I'm more than happy to talk one-on-one and just really figure out whether or not this makes sense for your home. And I did see in one of the notes about we need to do this again for ground source, and I really do think that that sounds like a great idea, where I can likely bring on some ground source heat pump installers to kind of flush things out a little bit more fully and get you guys all the options.
Thank you so much, Mike. And thank you, Ryan, and thank you all for joining us tonight.